a problem on both send streams, especially the ones involving upstream and downstream motion. A boat can go 1 integer 3 by 5 kilometers upstream and 4 integer 4 by 5 kilometers downstream in 48 minutes, while it can go 2 kilometers upstream and 600 meters downstream in 33 minutes. So how much time in hours will it take to go 28.8 kilometers downstream? Now, the very interesting part of this particular sum is that the units are all very, very different, right? So distances are given in kilometers for three of them, but one of them is 600 meters. So I need to be careful to convert it. And the time asked is in hours. So the time in minutes must also be converted to hours. So 48 minutes can be written as 48 by 60 hours, and 33 minutes can be written as 33 upon 60 hours. So let's understand all the data which is given to us and write it down. The distance upstream is given to me as 1 integer 3 by 5 kilometers, that is 8 upon 5 kilometers. The distance downstream is 4 integers 4 by 5, which is 24 divided by 5 kilometers. And the time taken for the first motion is 48 upon 60 hours. Similarly, for the second case, the distance upstream is 2 kilometers. The distance downstream is 600 meters, that is 3 upon 5 kilometers or 0.6 kilometers, and the time taken is 33 minutes or 33 by 60 hours. Now, I have to calculate the time taken to travel 28.8 kilometers. Now, in the first instance, the total time taken will be the time taken to travel upstream plus the time taken to travel downstream, which means the total time 48 upon 60 is, for time we know the formula is distance upon speed. So distance upstream upon speed upstream plus distance downstream upon speed downstream. And we know that the speed upstream is speed of the boat minus the speed of the river. Speed downstream is speed of the boat plus speed of the river. So if I take B as the speed of the boat, and if I assume that R is the speed of the river, then my first equation becomes 48 upon 60 is 8 upon 5 into B minus R plus 24 upon 5 into B plus R. Simplifying this, I get 1 is equal to 2 upon B minus R plus 6 upon B plus R. This is my first equation. Similarly, for the second case, I can get my pair set of equations as 33 upon 60 is equal to 2 upon B minus R plus 3 upon 5 into B plus R, which ultimately lands up as 11 is equal to 40 upon B minus R plus 12 upon B plus R. Now, in this case, to simplify the first and the second equation, first I'm going to assume that 1 upon B minus R is X and 1 upon B plus R is equal to Y. So my equations get converted as 1 is 2x plus 6y and 11 is 40x plus 12y. So solving these two equations as linear equations, I will get the value of x is 1 by 4 and y is 1 by 12. So effectively, I can say that b minus r is equal to 4 and b plus r is equal to 12, which makes the value of the speed of boat as 8 kilometers per hour and the speed of the river as 4 kilometers per hour. So to go 28.8 kilometers downstream, the time taken to travel downstream is the distance downstream upon the speed downstream. The distance is 28.8. The speed downstream is boat plus river, which is 12, and this works out to 2.4 hours. So effectively, the time taken to go 28.8 kilometers downstream is option C, which is 2.4 hours. Be very careful in considering the values of all the given data and their units in particular.